Hello, space enthusiasts, and welcome back to the channel. Get ready for what might be our most mind-blowing live stream yet. The James Webb Space Telescope has just sent back its very first, real, jaw-dropping image of an object that's tearing through our solar system from another star. We are talking about 3IATLAS, the third interstellar visitor ever confirmed, and tonight we're diving deep into what this incredible object is and what it means for humanity. This is not a simulation, this is not an artist's impression. This is the real deal, captured by the most powerful space telescope ever built. 3IATLAS, also known by its official name, C2025N1, was first spotted on July 1, 2025, by the Asteroid Terrestrial Impact Last Alert System in Chile. It follows in the footsteps of the mysterious Oumuamua and the comet 2I Borisov, but this time, we have a front-row seat like never before. Stick around, because we're going to unpack everything from its incredible speed and bizarre trajectory to the burning question on everyone's mind. Could this be more than just a rock? So, what exactly makes 3IATLAS so special? First, let's talk about its journey. This object is on a one-way trip through our solar system. It's not gravitationally bound to our sun, which is the cosmic equivalent of saying it's just passing through the neighborhood. Its orbit is what scientists call hyperbolic, with an extreme eccentricity of 6.2. For context, an object in a perfect circle has an eccentricity of 0, and anything over 1 is unbound. So, 614 is off the charts, confirming it comes from deep space. When it was discovered, it was already barreling along at a staggering 61 kilometers per second. That's over 136,000 miles per hour. And it's only getting faster. As it gets closer to the sun, it will accelerate, reaching a peak speed of 68.3 kilometers per second at its closest approach, or perihelion, on October 29th this year. Now, before anyone panics, let's be clear. 3IATLAS poses absolutely no threat to Earth. Its closest pass to the sun will still be about 203 million kilometers away, placing it somewhere between the orbits of Earth and Mars. When it swings by our planet in December, it will be at a very safe distance of 270 million kilometers. So, we can all relax and simply marvel at this cosmic spectacle from afar. The real excitement isn't about any danger, but about the unprecedented scientific opportunity this visitor represents. We detected it much earlier in its journey than Oumuamua or Borisov, giving us a precious, extended window to study it with our best instruments. Let's talk about what this thing actually looks like. Unlike Oumuamua, which was just a point of light, 3IATLAS is an active comet. This means it has a coma, a glowing cloud of gas and dust surrounding its core, and likely a tail. This activity is a huge clue. It tells us the core, or nucleus, is rich in volatile ices, like frozen water, carbon dioxide, and carbon monoxide. As the comet gets closer to the sun, the heat causes these ices to sublimate, turning directly from solid to gas and creating that beautiful fuzzy appearance. This is classic comet behavior, but what's inside could be anything but classic. The composition of these gases can tell us about the chemical makeup of the star system where it was born, a place potentially light years away. The size of 3IATLAS is still a bit of a mystery, but estimates are fascinating. Early observations from the Hubble Space Telescope suggest its nucleus is somewhere between 0.5 kilometer and 5.5 kilometers in diameter. However, some data points to it being even larger, maybe as big as 10 to 20 kilometers across. If that's true, it would be significantly larger than Oumuamua. Its color is also intriguing. It has a distinct reddish hue. This, along with spectral data, could mean it's made of complex, large-grained dust, or has a unique composition we've never seen before. It's like receiving a geological sample from another solar system, delivered right to our doorstep. Perhaps one of the most mind-bending details about 3IATLAS is its potential age and origin. Based on its trajectory, astronomers have traced its path back to a region of our galaxy known as the Milky Way's thick disk. This is an ancient part of the galaxy, home to older stars. This suggests that the comet itself could be incredibly old, possibly over 7 billion years old. To put that in perspective, our own solar system is only about 4.5 billion years old. This means 3IATLAS could be a pristine relic from a stellar environment that existed long before our sun and planets even formed. It's a time capsule from the ancient universe, and we're finally getting the chance to peek inside. This early detection has triggered a massive coordinated effort among astronomers worldwide. The Hubble, the Vera C. Rubin Observatory, and of course the James Webb Space Telescope are all pointed its way. The data is already pouring in, and it's confirmed the presence of water ice and vapor, which is a fantastic start. But that's just the beginning. The James Webb has more observation time scheduled for this August, and again in December. During these sessions, it will use its powerful infrared instruments to perform detailed spectroscopy. This will break down the light from the comet's coma into its chemical fingerprints, revealing the exact molecules present. Are there organic compounds? Elements in ratios we don't see in our own comets? Each new piece of data adds a pixel to the portrait of a distant, unknown world. Now let's address the elephant in the room. Whenever an unusual object from interstellar space visits us, the big question arises. Could it be artificial? Is it an alien probe? Renowned astronomer Avi Loeb, who famously suggested Oumuamua could be an alien artifact, has naturally raised the same possibility for 3IATLAS. He points to its unique characteristics as reasons to keep an open mind. And he's not wrong to be curious. We should investigate every possibility. However, it's crucial to state that the overwhelming consensus in the astronomical community is that 3IATLAS is a natural object. So far, it's behaving exactly as a comet should. There's been no sign of non-gravitational acceleration beyond what can be explained by the outgassing of its ices, and absolutely no detection of any technosignatures, no radio signals, no strange heat patterns, nothing to suggest it's anything other than a fascinating but natural piece of cosmic debris. So, can you see 3IATLAS for yourself? Well, right now, it's pretty tough. It's currently at a faint magnitude of 18, which means you'd need a fairly large telescope, at least a 6 to 16-inch model, and specialized CCD imaging equipment to even get a glimpse. It's hanging out in the evening sky in the constellations Sagittarius and Libra. However, the good news is that it's expected to brighten as it approaches the sun. By its perihelion in late October, it might reach a magnitude of 11. That's still too faint for the naked eye, but it would bring it within reach of advanced amateur astronomers with good equipment. It will disappear into the sun's glare for a bit around that time, but then it will reappear in our morning sky in November and December, passing through Virgo and Leo as it heads back out into the void. The discovery of 3IATLAS highlights how much our technology has advanced. We are getting better and better at spotting these interstellar travelers. Looking to the future, this is just the beginning. The European and Japanese space agencies are planning the Comet Interceptor mission, set to launch around 2029. This mission is designed to sit and wait in space for a new, pristine comet or an interstellar object just like this one to be discovered, and then rapidly fly out to meet it for a close-up encounter. Unfortunately, 3IATLAS is moving too fast for us to send a dedicated mission to it now, but it's the perfect practice target for our observation skills and a powerful motivator for future intercept missions. What we are witnessing is a pivotal moment in astronomy. For centuries, we could only study the objects within our own solar system. Now, we are beginning to analyze pieces of other star systems. Each interstellar object is a new chapter in a story we're just beginning to read. What will Webb's next observations in August and December reveal? Will we find a chemical composition that completely rewrites our models of planetary formation? While the idea of an alien probe is tantalizing, the scientific reality is, in many ways, even more profound. We are directly sampling the building blocks of another part of the galaxy. This is real, tangible data about how stars and planets form elsewhere in the cosmos. Thank you so much for joining this special live stream. The universe has sent us a message in a bottle, and we're here to uncork it together. Don't forget to like, subscribe, and hit that notification bell so you do not miss our updates as more data on 3IATLAS comes in. Stay curious, everyone.